if you recall dot product, right? The process of dot product, when you multiply two vectors, the answer wasn't a vector, it was actually a numerical value, right? Converted into a numerical value, right? Some k, right? Now that's weird because we multiply two things that are vector, but they cease to become vectors anymore. So we define a new form of multiplication, and this time the purpose of the multiplication is this. If you multiply these two, okay, if you multiply the vector b and a, you get this vector that's perpendicular to both of them. Okay, perpendicular to both of them. Okay, so there's we can express x, y, z all in terms of a1, a2, a3, b1, b2, b3. Okay, the idea is that if we define it this way, isn't it true that if you have n times by a dot product, that will be 0, right? Because they're perpendicular. And so will n times by b. So that'll be 0. And that'll be 0. Okay. Alright, so let's try to express x, y, z all in terms of a and b's. So from dot product, we get a1x plus a2y plus a3z is equal to 0. And we get b1x plus b2y plus b3z is equal to 0. Alright, let's call this one here equation 1, and let's call this one equation 2. Okay, there's three unknowns here, x, y, z, okay? Let's eliminate the variable z, and the way to do that is to match the coefficient. So for equation 1, if you just multiply by b3, for equation 2, if you just multiply by a3, okay, let's see what we get if we do that. We get a1 b3, a2 b3, x, y, and a3 b3 z. Okay, I'm going to list this equation 2 at the bottom here. We get a3 b1, a3 b2, a3 b3 z. Do you see how it matches up exactly? Let's subtract. Okay, let's do a subtraction. Then this will cancel out, and we have the following. We have a1 b3x, right, minus a3 b1x. So you can actually factor out the x, plus, okay, for the y you get a2 b3 minus a3 b2 y is equal to 0. Okay, let me just bring this over to the other side. Okay, you get minus a2 b3 a3 b2 y. So now do you see that if one way to satisfy this equation is this: if x was equal to this part, and if minus y was equal to that part, do you see that they will equal to each other? So let me replace it like that, okay? Let me replace the x with a2 b3 minus a3 b2. Okay, let me keep the other one same. Okay, and then the minus y, the minus y, I let it be this. Oops. Try to pick a right color here. So A1 B3 minus A3 B1. It becomes exactly the same, right? You see what I'm saying, right? Okay. So look, if x was, so what I'm saying now, n, which is x, y, z, if x is exactly this part here, a2, b3, right, a3, b2, and if y is exactly minus of this one, so minus of a1, b3, a3, b1. Okay, so let's actually take a look at pattern here. Do you see what I have here is this a2, b3 subtract by a3, b2. Okay, so actually let's take a look here. So remember the first vector A was the following: a1, b1, sorry, a1, a2, a3, right? And the vector b was b1, b2, b3. So the first coordinate is a2, b3 subtract by a3, b2. So it's a cross multiplication of these four things. Okay, now take a look at the second one. A1 and B3 is right here. A1 and B3 and A3 and B1. Do you see it's at the corner? It's everything but omitting this one in the middle. It's a cross multiplication of those two, but with a minus in front. Okay, now if I just, instead of eliminating Z, if I did the same procedure and I eliminated X instead, the last one will become A1 times by B2 minus A2 times by B1. Okay, so this is a cross product. Okay, so this right here is a vector that's perpendicular, right? We know because of the way we derived it, it's perpendicular to both A and B at the same time. So if I were to actually multiply this negative in, right? I get x, y, z is, let's just multiply it in, and we get a3 b1, a1 b3, a1 b2 minus a2 b1. Okay, look, this is too hard to remember the way it is. There's too many like 1, 2, 3s everywhere, right? So look, if I have a1, a2, a3, and just write it one more time, a1, a2, a3 in the same pattern, b1, b2, b3, b1, b2, b3. And look, if I want the x coordinate, I just cross multiply these two. So look, you have, if you cross multiply these two, you get a2, b3 minus, you always put a minus, the difference of a3, b2.
But why is it?
Okay, so now if you want this y value, look, you cross this one out and you do a cross multiplication. You get a1, b3. Oh, sorry. You don't look at these two, you look at these two. So you get a3, b1 and subtract by a1, b3. Okay, lastly, you cross that out and you cross multiply these two now. So always to the right. You get a1, b2, a2, b1. So this right here we call A cross product B. So this we call it, typically we call this a normal vector, and by definition the normal vector is perpendicular to A as well as, right, B, because that's the way we derived it.